Section 16.1 talks about vector fields. So a vector field, this is what we're going to use in all throughout the majority of chapter 16. A vector field on two-dimensional space is a function, it's really a vector, that assigned to each point xy a vector in that dimension, and if it's 3D, then xyz would point in the xyz. Here we're going to do a bit by hand just to get an idea of how this works. The point is not really here for you to master this and be able to get the graph by hand. That's not what you should be concerned with. It's more of, can you get an idea of what do they mean by a vector field? So I always like to think of a vector field something like liquid moving. Movement of liquid. It could be energy. It could be solar power. It could be gravitational force. It could be anything. I like liquid because it makes sense. Or solar. So if I take the point x, if I take the point y, I would like to know my vector field would be what. So if I start and I pick a few points, again, this seems to be kind of primitive. It is, but we want to get an idea. So I'm going to circle around those. Now, how many points do I need? Not even as many as I'm labeling. But we just want to get an idea of what this vector field is doing. And if I take the first point, let's say, well, obviously 0, 0, I am at 0, 0. So I'm right there. But if I go to the point, let's say 1, 0, then it looks like my vector is 1, 0. So I go to the point 1, 0, I am right there, and the vector is move 1 in the I direction. What if I go to 2, 0? What would happen? 1, 2, 0. It seems it stretches out even further. Okay, how about 1, 1? What would happen at 1, 1? Let me go with the green. 1, 1. I'll notice that I'll be looking at 1, 1 as well. So 1, 1, I'm right there. I'm going to go 1 in the I, 1 in the J. What if I went to 0, 1? 0, 1. So if I go to the point 0, 1, the vector is 1 up. So it seems if I go to negative 1, 0, from this point, if I go to negative 1, negative 1, I'm sorry, negative 1, 1, right there, it seems this is going to be negative 1, 1. So negative 1, 1. Okay, I'm kind of guessing now, because if I continue this list, if I pick more, and let me make it another chart. So if I pick the bottoms, my guess, because they're the same, there's really not much, no trick there. If I go to negative 0, negative 1, that point right there, well, it's 0, negative 1. It's repeating. So negative 1, negative 1, and 1, negative 1. So this is dispersing in every direction. And we're going to be trying to figure that out in the next section. There is circulation and there is dispersion, flux versus circulation. So I get an idea of how this looks like. It looks like this is going to look like, and of course, if you look at a graph using some kind of software, you'll see a whole bunch of arrows pointing outwards or inwards or circulating or not. How about this right here? Well, I'm going to do the same. I want to pick a few points. Again, I don't have to pick a whole bunch of points, but a few points to get an idea. And we need 2 of those tables, so let me copy it twice. And let me extend that a bit. And there it is. Now, if I pick an x and a y, f is negative yx. So let's see what happens here. Again, if I go for the origin, it is the origin. If I go for the point 1, 0, this says 0, 1. 0 at the point 0, 1. So 0, I, 1 in the j. Okay. What if I go to the point 1, 1? What would happen? If I move to the point 1, 1, this says negative 1, 1. If I am right here, you move 1, 1. Okay. How about if I am to run to the point 0, 1? So I'm trying to get all of these points. 0, 1, that seems to be negative 1, 0. 0, 1, negative 1, 0. How about the point negative 1, 1? That point. Well, this says multiply the x by negative, and so here oh, I'm sorry, this point is negative 1, 1. Let me just make sure. The x and negative the y. So negative 1, negative 1. That seems they're circulating. Okay, how about the point negative 1, 0? If I went to negative 1, 0, then that's going to be, so 0, negative 1. Okay, couple more to go. What if I decided to run down to 0, negative 1? 0, negative 1, that is 1, 0. Okay, yeah, I'm certain right now it is circulating. If I run to that point 1, negative 1, that point right there, switch those, that is okay. So it seems things are running in a loop, sort of like circulating, and here things seems to be just being pushed outwards, and it's not always one or the other. It could be a combination. It's very hard to draw. Just getting an idea of what that looked like. And if I look at this, and again, we're gonna be asked to sketch graphs of those that are really straightforward, nothing very challenging. So think about it. This is really 0, 0, negative x. So if x equals 0, I am on 0, not a problem. Doesn't matter what x and y are. If I move to x equal 1, 0, then at the point 1, 0, 0, this is pointing 1 down. Same here. Along this whole line, x equal 1, the vector is pointing downwards, the vector field, with a magnitude of 1. What if I go to 2? X equal 2. Oh, and it doesn't matter how high I go. Even if I went up, that's still gonna run straight down. 1 unit, as long as x is lining up with 1. X equal to 0, 0, negative 2. So it seems the further I move in the positive x direction from the origin, the stronger the field is pulling downwards, right? And if I go to 3, of course, it's going to pull even harder down. If I move backwards, if I move to negative 1, then it's going to be pointing upwards. If I move to 2, 0, 0, 2, so it seems the further I move back, the higher this is going to go. So the further I move in the negative x-axis, the higher the force field is going to be, or the push of the water, or the current, or the gravity field is going to be pushing up in the positive z direction. And that's all there is for this section. You just need to get an idea of what those fields look like. They have some in the book that are used using Mathematica, using MATLAB, all of these softwares. I'll demonstrate some of those. I'll show you some of those next time.